So we start off with our last and final class on the chapter of integration, and today we are going to discuss about the different properties of integration. Now in this class we are just going to deal with the properties. We will be discussing or trying to prove a few of them, and obviously rest we will just write them as properties. So let me just write down the properties first. Now the first property that we have, it is integration a to b fx dx, that is equals to integration a to b ft dt. So that means that we are talking about the change of variable. So if we change the variable, then also our integration remains all the same. So nothing happens. Then number 2, if we have integration a to b fx dx, then now obviously we use this property before also, that becomes minus integration b to a fx dx. Fine. And if we can see that the limits become equal, then the integration becomes 0, right? Then the third one, we have integration a to b fx dx, that is equals to integration a to some c fx dx plus integration some c to b fx dx. Fine. Then number 4, integration a to b fx dx, that is equals to integration a to b f of a plus b minus x dx. So we will definitely try proving this fourth one. Fourth one is a very important. Now this is a very generic property. We will try proving this one. The first few, I think we really need not prove. It is something we can see that it happens very obviously. Now number 5.1, it's derivative, or not, I shouldn't say derivative, it is derived from this number 4 actually, that if I have 0 to a fx dx, then that is same as 0 to a f of a minus x dx, right? Then number 6, if I have 0 to 2a fx dx, that can be written as 0 to a fx dx plus 0 to a f of 2a minus x dx. Let me erase this part. Then number 7. Now it is a special case of the number 6. If f of 2a minus x becomes equal to fx, if it happens, then this integral, as we can see pretty obviously, this integral 0 to 2a fx dx will become twice of 0 to a fx dx, because this 2a minus x will become fx, so fx plus fx, it will become twice of fx. And obviously if f of 2a minus x becomes minus fx, then integration 0 to 2a fx dx will become 0, right? And the last and the final one, number 8. Number 8, we have integration minus a to a fx dx. This becomes twice of 0 to a fx dx if fx is equals to minus fx and minus a to a fx dx, it becomes 0 if fx, I'm sorry, this should be f of minus x here, is equals to, hold on, f of minus x is equals to f of x, and here f of minus x equals to minus fx, right? So that is, in a way, if the function is an even function, then this becomes twice the integral. If it is an odd function, then the integral becomes 0. So now let us prove them. Let us prove at least one or two, and then we will move into the problems. Now let us take number 4 and let us try proving number 4, because number 4 is very important. So number 4, it was integration a to b fx dx, and I am supposed to prove that this becomes a to b f of a plus b minus x dx, right? This is what I need to prove. Now let us start from this side. This is the RHS. Let us start from RHS. So from RHS, if we start, that is integration a to b f of a plus b minus x dx. Now let us take a substitution. Let a plus b minus x, that is equals to some t. Fine. If we take this substitution, then what happens? Then what happens? Then minus dx will become dt. So therefore our integration, and also let us see what happens when x is equals to a, then t is equals to b, and when x is equals to b, t is equals to a, right? These are the changes that happens. Now if we put those in the equation, put it back here, then what do I have? We have minus b to a ft dt. We have minus b to a ft dt. Now obviously if I absorb the minus sign, it is our second property, then definitely it becomes integration a to b ft dt, right? Now we already know that I think there is a reflection that is coming. I hope now it is visible. So now we know that doesn't matter whatever the variable is, my integration remains all the same. So therefore I can change it back to our original variable and I can write this as a to b fx dx. This was the first property. So therefore I started from the right hand side and I proved the left hand side. Right? Now let us take another one and let us try proving it. Now let me see which one to take. Let me take, say, number 6. Number 6 is also important. So let us try proving number 6. So number 6, we have integration 0 to 2a fx dx, that is equals to 0 to a fx dx plus 0 to a f of 2a minus x dx. This is what I need to prove. Okay. So once again, here what we are going to do, we are going to start from the right hand side. Let us start from the right hand side. Now if we want to start from the right hand side, what to do? Let us start from here. Now obviously this part is fine, I don't have any problem. So let me consider something here. So if 2a minus x is equals to some t, once again, then minus dx is dt, right? This is what we have. So therefore plus, now obviously when x is 0 then t is 2a, and when x is a, t is a. So I have, now this plus will become minus, let me just make it minus. Now when x is 0, t is 2a, so here there is a 2a, and when x is a, t is a, so ft dt, right? I can write this, see for yourself. Now once again, as I know from the first property, if I change the variable back to its original variable, nothing happens, it remains all the same. So let me change it back to our original variable. So therefore I can write here 0 to a fx dx plus, okay, if I'm making it plus, then it will become a to 2a fx dx. I just changed the variable from t to x. I can do that by first property. So now see here, 0 to a to 2a, then this is going to become 0 to 2a. This is the third property which we learned. So therefore this is 0 to 2a. fx dx, which is our left hand side. Fine. So therefore we just proved two properties, and rest of the properties that we have, they are all derived from this two main properties, that is property number 4 and property number 6. Fine. So now it will be our job to move into the problems. So let us take few problems and solve it. Okay, so now let me take few problems and solve. Let us move on to the exercise. Okay, so let us start with a very simple and easy problem. So problem number 1, integration minus pi by 4 to pi by 4 sine square x dx. Let us do this. So this integration we are pretty much acquainted with. We know what to do with sine square. Now minus pi by 4 to pi by 4. Now let us check this for once. What happens to sine square? So sine square of minus x, that is of sine x, sine of minus x whole square. So it is minus sine x whole square, so it remains sine square x. So therefore I can see f of minus x is f of x. Now do you need to show this? Definitely you need not show this, but I'm just trying to show you that to apply a certain property of definite integral, this background thing has to be there. If this background thing is there, then only I can apply the property. So means this will actually become twice of 0 to pi by 4 sine square x dx. Now obviously I can write this because of this. Fine. So now obviously you need not show it. This you definitely need not show it. Okay. So now rest of the integration is just a normal integration. See here. Now 2 goes inside, so therefore 0 to pi by 4, this becomes 1 minus cos 2x dx. So therefore it becomes x minus sine 2x by 2, 0 to pi by 4. Now if you put pi by 4, then this becomes pi by 4 minus sine 2 into pi by 4 is pi by 2 half, and if you put 0, both are 0, so therefore this is your answer. Correct? I hope it is clear. Then let us move to the next problem once you have understood this. Next problem, number 2. Now this type of problems, they are one of a kind. Now those who will be attempting section B, for them it will be a little bit helpful. 2 to 8 mod of x minus 5 dx. Let us take this problem. Now till now we haven't done integration of any modulus function. So integrating a modulus function, it is a little bit there are certain background works that we need to do. So let us just first understand how to work with modulus function. Now see what is modulus function. We already did this so many times. Modulus of x minus 5, that is actually equals to, it is a case function, minus of x minus 5 when x is less than 5, and x minus 5 when x is greater or equals to 5. We already know this, that this happens. Now, therefore, when we have this integration from 2 to 8, so integration 2 to 8 can be divided into 2 to 5 mod of x minus 5 dx plus 5 to 8 mod of x minus 5 dx. We can do that. This is by property 3. Now, we can see modulus function does not have a constant graph throughout, but there is a branch. So the branching point is 5. So therefore, what to do? We have to take that particular branch from 2 to 5. 2 to 5 is less than 5. So therefore, I will take this branch, and 5 to 8 is this branch. So therefore, the integration becomes minus 2 to 5 x minus 5 dx plus 5 to 8 x minus 5 dx. Fine, simple. So now let the minus sign be outside, or we can just absorb it in. So then it becomes 5 minus x. So therefore it becomes 5x minus x square by 2 from 2 to 5 plus x square by 2 minus 5x from 5 to 8. Now it's just about calculation. So fine. Let us move to question number 3. Now, this kind of problem, generally they don't come in your board exam. Even though if it is there in the syllabus, this still also it doesn't come. But obviously, for section B part, this kind of integration may come. Means if you have to work with curves where you have modulus functions. Let us take the next problem. Problem number 3. Problem number 3. Problem number 3. Integration 0 to pi x sin x by 1 plus cos square x dx. Now this is a very important problem. Let me just mark it, because this is a very typical type of a problem, and there will be many problems which you can solve exactly like this, the way this one is solved. Fine. Now how to do it? Now while you are solving this, whenever you have problems like this, the first thing will be to consider an I. So I will consider this whole integral as I. Now I can write this I as 0 to pi minus x into sine of pi minus x by 1 plus cos square pi minus x. This is exactly the property integration fx 0 to a fx dx, that is equals to integration 0 to a f of a minus x dx. Now obviously you need not show it, prove it, you can directly apply it. So see here what are the things happening if I apply. So this will give you 0 to pi minus x. Sine of pi minus x is sine x. Cos of pi minus x is minus cos x, but it whole square, so therefore it remains 1 plus cos square x dx. Right? Now, obviously, if I take this pi out, so this will give you pi into 0 to pi sine x by 1 plus cos square x dx, and minus you see 0 to pi x sin x by 1 plus cos square x, so that is pretty much your I, right? So now please don't mind the disturbances in the background. So now 2i becomes pi 0 to pi sin x by 1 plus cos square x dx. Okay, then now rest of the integration is very simple, because then you take cos x as z, then sin x dx becomes dz minus dz. So let cos x as z, then minus sin x dx, that will become dz. So integration will be changed into, now let me just put it here. Now see, if x is 0, z is 1. If x is pi, then z is minus 1. So therefore our integration becomes minus integration 1 to minus 1 dz by 1 plus z square. This is what the integration becomes. Now if I absorb the minus sign, then this will become minus 1 to 1 dz by 1 plus z square. Now obviously minus 1 to 1, that is, it will become twice of 0 to 1 dz by 1 plus z square. Right? Then now dz by 1 plus z square, that is tan inverse. So 2 into tan inverse z 0 to 1. Now for 1 it is pi by 4. So therefore your answer is pi by 2. If you put 1 here, then it becomes pi by 4. Then if you put 2 into pi by 4, that is pi by 2. But remind you, this pi by 2 is the answer for 2i. So 2i is pi by 2, and hence I is pi by 4. I could have done what? I could have cancelled 2i with the 2 and 2 here, but I didn't have the space to write. So therefore this is your answer. Fine. Oh, sorry, I think I missed something. There is this pi here also. So if there is a pi, so here there is a pi, here there is a pi, here there is a pi. So I just missed that pi, so it becomes pi square. Okay, I missed this pi. So this is the problem when you do something on a big place. You know, it is very difficult for you to have everything right in front of your sight. So I just forgot that pi. There is a pi. Okay, let us move to the next problem. That is problem number, I think this was third one. So let us move to problem number 4. Now problem number 4 is basically a simple problem, and there are so many problems of that kind which is very easy to solve. It is problem number 4. It is 0 to pi by 2 sine to the power 4x by sine to the power 4x plus cos to the power 4x dx. See, simple problem. Now why I am doing this? Because there are many problems of this sort or this type which you will come across. So just you need to do only one thing. See here, consider this as I, obviously you need to consider this as I. So if I consider this as I, 0 to pi by 2, I can write this as sine to the power 4, right here pi by 2 minus x by sine to the power 4 pi by 2 minus x plus cos to the power 4 dx. Now obviously this will give you integration 0 to pi by 2 cos to the power 4x by sine to the power 4x plus cos to the power 4x dx. Now consider this as your 1, consider this as your 2. If I add these two up, then adding 1 and 2, then I get 2i, that is equals to 0 to pi by 4, 0 to pi by 2. Now sine to the power 4x plus cos to the power 4x in the numerator, denominator is same both the cases, so this will actually become, okay, let me write it first, sine to the power 4x plus cos to the power 4x by sine to the power 4x plus cos to the power 4x dx. Both gets cancelled, you get 0 to pi by 2 dx, that is pi by 2, but 2i is giving you pi by 2, so therefore I is again pi by 4, right? Simple problem. Now let us take the fifth problem. Now this fifth problem is like a bumper problem which is very important. Now this problem, solving this problem will give us idea to solve problems of this particular type, that is 0 to pi by 2 log of sin x dx. Now whenever I am trying to solve this, there are so many problems of this kind which you will come across, and this is the most basic type of it, and all the problems of this kind have to go through a step where you will get this integral embedded inside that problem, whichever the problem be. You can find an integral which is like 0 to pi log of 1 plus cos x dx. This is a problem which is definitely solved exactly the way this one is solved, but you will find that while solving this integral you will come across this integral. So therefore let me solve this basic integral first, then obviously while solving this other integral you will know how to solve the other ones. So now see here, I can write this 0 to pi by 2 log of, now sin x, sine of pi by 2 minus x, this becomes cos x dx. You need not show it directly, all the time it is obvious certain steps. Now 2i will become 0 to pi by 2 log of cos x plus log of sin x, so that becomes log of sin x cos x dx, right? Then what we have, so 2i can be written as 0 to pi by 2 log of dx. This is what we can write. Now see this, log 2 dx. This by 2 comes out as a negative. Then let us come back here. So see what are the things that we can do from here. We can write this 2i as 0 to pi by 2 log of sine 2x dx minus, now log 2 is a constant, comes out, so 0 to pi by 2 dx, it becomes pi by 2 log 2, right? Then let us take a small substitution. What is the substitution that I want to take? Let us take 2x as something. So let 2x is equals to some z, then 2 dx becomes dz. So in that case, this integral becomes 0. Now obviously if x is 0, z is 0. If x is pi by 2, then it is pi. So 0 to pi log of sine z dz, right? Obviously with a half outside. Yes or no? So therefore I can write this 2i as half integration 0 to pi log of sine z dz minus pi by 2 log 2. Check it out. Then this pi, if I write half into 2 into 0 to pi by 2 log of sine z dz minus pi by 2 log 2. Yes or no? So therefore this 2 gets cancelled. But what is this? This is exactly the integral we started with. We started off with 0 to pi by 2 log of sine x dx. Now doesn't matter it is sine x or sine z, the integral remains the same. So therefore this can be written as, so 2i can be written as I minus pi by 2 log 2. So therefore finally my answer is I, that is equals to minus pi by 2 log 2. Right? So this is basically our integral. This is exactly what our integral is. Now I will take you to another problem. I am not going to solve it completely, but I am going to show you how I am going to come across this integral while solving that problem. So let me just take the problem, question number 6, 0 to pi log of cos x dx. This is our problem. So here if I consider this, see, I can write this as 0 to pi log of 2 cos square x by 2 dx. Yes or no? If I can write this, let me just quickly take you through the problem. So therefore again this 2 is there, so therefore I can write this as 0 to pi log 2 dx plus 0 to pi. Now obviously cos square is there, so if I take this 2 out, it becomes log of cos x by 2 dx. Yes or no? So now let us focus on this problem. This is I2. So I2, that is 0 to pi log of cos of x by 2 dx. Now this x by 2, if I consider this as something, so let me consider this as z. So if I consider x by 2 as some z, then dx by 2, that is dz. So therefore this integration becomes, now obviously if x is 0, z is 0. If x is your pi, then it is pi by 2. So 0 to pi by 2 log of cos z dz. But what is dx? Dx is 2 dz. So there will be a 2 here. Right? Now this I2, that is 2 0 to pi by 2. Now this pi by 2 minus z, then this becomes 0 to pi by 2 log of sin z dz. We come back to the very problem we started with. That is, this is the problem we did, that is the fifth one, and we already know what is the answer to the problem. So therefore let us just write what the answer is going to be. I am not going to solve this once again, but if this problem comes, then definitely you have to solve this as well. So therefore your final answer, that is I, this is what we started with. Now 0 to pi log 2 dx. So 0 to pi log 2 dx, that is your pi log 2. That is your pi log 2, obviously. Now 2 into I2. So this is 2I2. So let me first write what answer this is. So this is 2 into minus pi by 2 log 2. So that is minus log 2. Sorry, that is minus pi log 2. And here there is a 2. So therefore this is minus, let me write this first. So this is minus pi log 2. But here there is a 2, so therefore this is minus 2 pi log 2. So therefore your final answer is minus pi log 2. So therefore this is what your question is. So whenever you have a problem like this, you will always come across such integral, that is log of sin z. Okay? So this is basically it. So that concludes our chapter integration, big chapter, and pretty much the main part of calculus, that is, it is completed. And now we will start off with our optional part, that is section B and section C simultaneously. So let us meet once again on maybe Friday or Saturday. Okay, so thank you.